Good morning and happy Friday to you. Welcome to the ICAT Playdate. My name is Phyllis Newbill. I am the Associate Director of Educational Networks in one of the centers at ICAT. I want to welcome you this morning. A few housekeeping things. One is that we are filming this morning in 360. So this fabulous object in the middle of the room is a camera, and it's looking at all of you. And you're being live streamed onto the internet for everyone to see, just so you should know that. And it will exist online afterwards. So I would love it if you all would sign in. Our sign-in sheet lets us know who comes and also allows us to justify additional donuts for future play dates, so it's very important. So I'll start the sign-in here. If y'all get that going. Please do enjoy donuts and coffee. As always, when you have questions this morning, when we get to the questions and demo time, just make sure that questions for the online audience are into a mic so that our online audience can hear us. Good morning, friends, in the online audience. And if you're online and you have questions, please feel free to put them into that to the question box there, and we'll get those and get those asked. Finally, if you're a faculty member and PDN credit is helpful to you, make sure that you register and let me know that you're here. If you're watching online, shoot me an email or put a note in the questions box so that I know you're here. Couple of announcements this morning. We do have the Science Festival coming up on November 12th. Hope you'll all be at the Moss Art Center or Newman Library and Newman Library and Torgerson Bridge for that. Lots of great hands-on science and science explorations. So I hope you'll be there. That's from 10 to 3 on November 12th. Todd, there is a guest speaker coming soon.
Hi, everyone. Nicholas Emquist is here from the iSchool at University of Maryland College Park. He'll be giving a talk this afternoon entitled Anytime, Anywhere, All at Once, Data Analytics in the Metaverse, from 1 to 2:30 in the library multi-purpose room. Does anybody know where that is? Does everybody know where that is? If you go into the cafe, the coffee shop on the ground floor of the library, I think everybody knows where that is. It's just up behind that. The big room, it's kind of on the left. So look for us there at 1 o'clock. Thank you.
Awesome. Thank you. And so today, I'm wearing two hats this morning, so I'm both hosting and helping to present a little bit too. This is MOVIS, the mobile-based VR. And this project is it's a team I've been on for a while, but I'm going to turn it over to Sang, who will get us started. And y'all just hold on to your seats. This is going to be super fun.
All right. Can you hear me fine? Great. Well, thank you very much, Phyllis. So my goal here today is to make it quick so that you can experience this demo. So you can see, as you can see, we have installed this demo since yesterday, and then these students took a long time to get it work, and so I just wanted to make it quick. So think about Science Museum. Science Museum is a great example for informal learning. And it's a great way to engage children and kids to learn STEM materials like, solar system or Jurassic Park. That would be great, right? But wouldn't it be great if we can use VR? Like if you use VR, we can make it interactive, we can make it immersive, and they can actually see and then interact with the virtual object, and then they will feel like they're in there, right? But there's one problem with VR. VR headset is not yet inclusive enough for everyone to use. So you can see this stock image where a 3-year-old kid is wearing VR headset that does not exist in real world because manufacturer does not recommend children under 13 to wear a VR headset. And there are a lot of people who experience nausea, so they're kind of freeze and do not want to move when they wear a headset, or feel dizziness and nausea, and it could lead to injury and fall. And there's other reason that people may not be willing to wear a VR headset for maybe someone has a thick hair texture, or they don't want to ruin their hairstyle or makeup. But there are a lot of reasons, or maybe it could be a hygiene reason. But you can imagine that people may not want to bother to wear a headset. So this is the project that we worked on 2 years ago. It was funded by ICAT. It was one of the ICAT seed grant project. So we want to use, interestingly, we wanted to downgrade the technology and use a tablet device for people to view the VR world through the device, as if you'll be able to see the real world through your smartphone camera, right? So we developed the system, and if you came to my talk last year, you may remember this particular video. I brought my son to the user study setup, and then he was kind of playing with the VR headset user, and then he was able to play with my student, and they were playing Pictionary game. And I would not let him use VR headset, but I'm fine with letting him use this tablet. I didn't videotape it for the purpose of demo, but I realized this is the best demo that we can use. So we came back with a bigger system. We proposed this work to NSF, and they sponsored us to come up with a platform that like a number of people and create a social setting where people can learn STEM material. So what's interesting about Science Museum is that you don't know who's coming. It could be like grandparents and grandkids, or instructor and students. So we wanted to make it inclusive option, so we used this tablet-based VR. So we are about to deploy this in Science Museum, but before that we run a study, and to run a study we develop a simple stupid game. It's like a game where you can, like competing, team-based game. You're competing each other to change the color of the balloon. So if you're in a red team, if you poke it, it's gonna change it to red. If you're in a blue team, and then it's gonna change to blue. And then we can have up to 12 people, theoretically. And in practice, you can imagine the tablet could be shared with a pair of students, so that like you can imagine we can have more than 12 students if it was a learning setting. I'm going to briefly talk about what we did. Like we had a two-factor. We wanted to check the effects of group size and also how quickly they move. And we cannot force them to move like quickly or slower, so that we created these two different types of interaction type. One was to poke the balloon, where you have to approach the balloon and then poke it, and the other case was like shooting a bullet towards the balloon so that you can interact with it in a distance. And then it was within subject study, which means that each participant were able to experience 6 different conditions. Rather than present the result, I wanted to show the video footage of the experiment, and then you will be able to see the difference between poke and group size. So the poke is basically you approach the balloon and then basically poke the balloon to change the color, and then you're not going to be able to see what's going on, but they're having fun. Some people are having too much fun, it looks like. And then this is shoot, so it's kind of like a more static interaction type. So you approach the balloon and then shoot a bullet, and then it's going to change. So yeah, there's some competitive people. But yeah, think about this. Have you ever seen this large scale of VR somewhere? You can obviously there's some great platform where it will support a number of VR headset users to be able to play with, interact with each other, but this does not require site-specific platform, and this could be installed anywhere. We installed this system here, so it could be installed in the Science Museum too. So you can imagine that this could be useful to engage kids to teach STEM material. We have a lot of scientific finding. I'm just having it there so that if you're interested, you can go back to YouTube and then stop it and read all these. But basically, we were able to extract the implication that will be helpful to design these kind of content. So yeah, I'm going to hand it over to Todd, who has been working on creating content for this platform. And yeah.
Thank you, Seng. So the first activity that we're going to talk about and demonstrate soon is about the solar system content, which is part of our NSF grant. It's a REDL grant to develop learning content and study the efficacy of technological and learning innovations in concert. And a lot of the team is actually here as well. So Sang is our PI. We have Phil Art, Phyllis, Chelsea, myself, Am I missing any of the PIs? And then Sang's lab of students and my students back here in the back who've been working on this thing for some time now. And Phyllis is going to come up and say a few things about our relationship with the Science Museum. But our goal is to use the affordances that MOVIS provides for that shared virtual experience without necessarily being locked in a headset on STEM content.
So a cool thing that we have at Virginia Tech is a science museum in Roanoke, the Science Museum of Western Virginia. We have a special relationship with them, so we have a liaison, who is usually me, that moves between the museum and the university and helps facilitate conversations and makes things happen. So we're actually going to install this exhibit in temporary ways at the Science Museum on days when there'll be lots of people coming through. And there's a lot of fun things about this. One is just the relationship between the university and the museum. There's a win-win. So for us as researchers, we have an audience, a real audience. And for the students of our region, they get to see this bleeding edge research. Informal learning is a different kind of space from the classroom. In the immortal words of Calvin and Hobbes, if nobody makes you do it, it counts as fun. So informal learning is what happens in museums. And so you sometimes know who's coming and what age they are and what kind of things they're interested in learning. And sometimes you don't know, and that unknown informal space presents both challenges and opportunities.
Well, we've talked about this for a moment already, but using the solar system as content and MOVIS as the platform, we're trying to allow socially constructed learning. So the kind of learning and pedagogical events that occur when you have groups of young learners, particularly in informal settings like science museums, that being one at a time in a headset doesn't allow for, in addition to the sorts of other issues that MOVIS helps to alleviate. What we have so far are about 7 different learning activities, but the ones that we're going to demonstrate today are observing the solar system at actual scale and observing the solar system at a scale that's actually practical for interaction, because you'll see in the demo that the solar system is actually quite large, surprise. And then we have a geocentric perspective so that we can look at the phases of the moon and help to demystify a little bit about that, building a virtual version of the old tennis ball and flashlight trick, if you know anything about that and the phases of the moon. Who knows, maybe you'll learn something today. Okay, here we go. So the work's being performed on the content creation and modifications to the system by students, undergraduate students, through the ARIES program, and they're all going to be here and walk you through what they've been working on today. But something to note that's important, because I'm a cheater. I'll cheat if I can, but they're doing this all actually properly using the physics and the mathematics that rule the solar system. So the simulations you see are actually based on the real physics of the orbits and how the light cast from the sun really is affecting the way the moon looks from our vantage point on Earth, dealing with scale issues that you'll see in the demo itself. So that's been, a lot of the work has been about the truth of the actual physics. We probably could have faked it all, but we didn't, so I'm very proud of them for that. So back to Zach now.
Yeah, and then we realized that this platform could be a great opportunity for artists as well, because it can create a group experience, like collective experiences of VR-based artwork. So we are collaborating Zach, Professor Zach Zuer, who is an original member of VR Viewfinder team. So I will let him talk about his artwork that he created, which we're going to demo here.
Thanks, Sang. So Sang and Philip invited me to think about making something that would work in this situation where you have someone in a VR headset and several people with tracked tablets. And one of the things I was thinking about is there's an opportunity to just make something that exists in VR space that can be viewed. And there's an opportunity to make something that works specifically with this setup. And I'm going to skip over that. We have limited time. Keep going. I don't know, I've been engaging with this word content recently. It's a very strange word, right, that we use a lot. Like, what's the content? What's the VR content? And I think I didn't want to make something that felt to me like content for to be consumed, in a VR space. And that's why I leaned toward the latter of making something that engages specifically with this technology. And so I was thinking a lot about how we move between the different kinds of spaces, the space that we co-inhabit together physically, the virtual space, and how we transition between spaces and between different ideas. And so I went back to an old collaboration that I'd never really been able to make work just for time with a friend of mine named Miriam Ekbal, who made these images of ballet dancers that she scanned across flatbed scanners while they were in the middle of scanning. And she made a beautiful animation. And so I took them and I made them into 3D models and used that as a starting space for material to work with in the virtual space. And it sort of evolved, and I'm just skipping through slides here without really talking about them. But what we ended up with is this sculpture, this sort of virtual sculpture that has an analog of a physical equivalent that James Cascadden, who's a student in the School of Visual Arts, created by hand. And the sculpture isn't here today, but it exists in the physical space with the artwork. And then there's one person with the VR headset on, 3 people with tablets, and they're all interacting both with each other and with the sculpture. And the way that they're moving together changes the way that the sculpture looks and the way it acts. And so if I go back here a little bit, playing with these ideas of how something changes and morphs from one shape into another. And so the interaction of people in the space, whether they're looking at each other, looking at the sculpture, how quickly they're moving, whether they're bunched up, whether they're spread out, those are all data points that are used to influence both this, the sculpture, in several different ways that we've been playing with in VR space. And then also I was trying to think of how to make avatars that represent people in virtual space without dictating too much while still giving them presence. And so this is what I came up with. So essentially when you're one of these cubes, whether you're a VR headset or whether you're a tablet user, and when you move, the avatar animates. And so it becomes humanish without being human. I think that's all I got. Thank you.
Great. So I think we're ready for demo. So we have 7 tablets for Solo System, and then 2 tablets and 1 VR headset for artwork. And Phyllis is going to help us to engage with folks who are online. But you can approach to us and ask a question. I just wanted to acknowledge the students' work. They have been working so hard to make this work, since probably for the last 2 weeks almost. So I just would like you to give it a big a round of applause to the students. Thank you. So it's time for demo. You can approach and then see the tablets over the shoulder and see what's going on. Yeah, Carlos here will help us to distribute the tablets.
So come on up. I'm going to second the encouragement for you to ask questions of the students, both behind the tables here and also from the Aries team. Your mind will be blown with what they have done and how they're building this. So I do encourage you to come on up. And for those of you who are online, I'm just going to kind of move through these and talk about things as we do the demos. So we'll hang on and enjoy with us. Enjoy the ride. All right. It's social VR. Are you married? Has a lot of tablets. Yep, I think we're good. Come on up. I think there's go this way. And they'll give you a tablet. All right, my friends online, are you enjoying this? It is so social and so VR. So right now, I think everything's at scale. At actual scale. So at actual scale, you can't even see the planets.
Scale, because as large as the planets are, the solar system is even bigger. I think, what, it's 4.5 billion kilometers out to,
Sounds about right.
out to Neptune?
Go ahead, keep talking through this.
Yeah, so as big as all the planets are, everything in the solar system is even bigger. So I think right now the sun might be the only thing that might be visible to you, so we have like green arrows indicating just because of how massive the universe is.
What's this guy? What's this orb?
That orb right there is the headset viewer. So you're able, while you're looking at the tablet, you're able to see where the headset viewer is.
Okay.
And
these-
then
these are tablets.
yeah, and so all of those are tablets. So I and the headset would be able to see where all of you are
This
located.
makes a lot more sense now. I was just like, those are weird planets.
You've got to crouch by the sun.
Yeah, like to see the sun, you're gonna have to crouch by it. It is in comparison to everything else. The sun, even the sun, is tiny. Like I said, 4.5 billion kilometers out.
We'll just pass the mic around. People can get a sense of what's happening.
They're all looking for sun.
Yeah.
Oh, yeah, you can see a little
See that like little that tiny yellow
little tiny dot is the sun.
orange dot right there.
So we had to choose our own physics engine for it all, and it's all calculating.
Talk in the mic while you're talking. That's good. No, talk into the mic.
Gotcha. So the physics engine was completely generated and written by our team. It's taking in all the masses of all the planets, their current velocities, positions, and it's calculating them in real time to display them in our current view type, which, as Atlas mentioned, is currently what the solar system looks like if you were to scale it to a 30-foot zone. So if everyone's ready, we can eventually move to view type 2, which is the view type we designed to be a bit more interactive. If you want to talk about it.
Yeah. So because everything is as small as it is compared to the universe, it's not really usable. So for our purposes, we chose to scale all the planets up to a more visible size, just for probably our own sanity. Is it up? Yep, go for it.
All right, we're switching to view type 2.
Go ahead.
It's going to take
It might just take a second.
the moon.
Wait, I'm going to ask a question.
Yeah, go ahead.
So how many times have you done this with a group of people before?
With a group of people of this size? Not yet. So congratulations on making it into the experiment. You are our test case.
Okay, it's slowly getting there.
Go for it.
So we actually haven't run a demo of this size to this length of time. So over time, we have been noticing some latency issue. It wouldn't be a demo if something didn't go wrong. So it should be switching to view type 2 right now. Are you guys seeing anything? There we go. We'll find a tablet to look at. So hopefully this would happen over the course of a couple seconds, just because the time issue. And then slowly we should see the planets resume their orbits. And something I really like in this view type is it really allows you to see the moon's orbit around Earth in the scope of viewing it as a sun-centered solar system. So once they start moving, you can see how the moon's orbit isn't perfectly circular or ovular around the sun. It sort of performs an oblong shape that you don't really see very often. They're happening. It's good. I will also mention that while these orbits are not exactly realistic, they are still performing the completely realistic math. It's simply just scaled to a more viewer-friendly point.
If you want to get in, you can. Just tell me to move.
I really want to see if we can do the seasons thing.
Yeah, we should do.
And then the other is the,
You talk in the mic, so the folks online.
The physics.
Oh, I was asking what was the hardest part of developing this?
Oh.
Go ahead. You talk to the folks online too, so they can hear what's going on.
Probably I know the moon was difficult. Yeah.
Why was it?
So we were running into a lot of issues with the moon because this is a sun-centered physics system. Is this microphone? Okay, I think it is. It's a sun-centered physics system, and so because of that, a lot of the data we have from NASA on like the physics and all that fun stuff is Earth-centered. So there's a lot of work that goes into converting that and trying to make it function. I don't think it's on right now.
It is, so I turned it off.
Oh, gotcha. There it is.
Yeah.
One of the things
Yeah.
we really want to iterate on here is to develop a more UI-centered feature.
Talking, it's, you'll be able, they'll be able to hear you
Yep.
online.
So one of the things. Hello?
You won't be able to hear it.
Gotcha. Okay.
Turn it down.
So, if we want. One of the things we want to continue to develop on is like the UI features and creating a more interactive experience with the tablet.
Do you want to hit moon phases? Hit it.
One more view type that we've developed. It's a little broken on the tablet right now, but we still want to show it.
So we had a question online about what kind of tablets we're using. Can you answer that one? What? We had a question online about what kind of tablets we're using and could it be used in a middle school classroom?
Okay, so far we've been using like different kind of tablets. So we have some Lenovo, some Samsung, like no high-profile tablets.
Okay.
So they are just more like in the middle range.
Okay.
So yeah, we've been using like 3 different types so far. 2 types of Samsung tablets and 1 Lenovo. That's what we have so far. But
Great.
nothing fancy, nothing special. No, it doesn't have to be like a super expensive iPad or something like that. So it's just like regular tablets. Yeah.
Excellent. And Alicia, you just let us know if you have additional questions about that. I'm happy to connect you. Great, thank you. Okay. We'll do it on time. Yep. So we're going to wrap up our official. Let me turn it back up. We're going to wrap up our official play date. So I want to thank everyone for coming. We'll give this team a big round of applause. The team is set up to continue for a while, and I do want to encourage everyone who's in the room to give us some feedback if you've done the participated in any way. So use these QR codes. We're doing some research today, and if you're willing to talk about your experience in the virtual reality environment, Ashley and Chelsea will be right here. We'd love to hear your feedback. Have a great day.